Hello everyone. Today I'm going to explain you the paper I'm going to present is Scalable Provenance Storage and Querying using Pig Latin for Big Data Workflows. In this paper, we are presenting the big data workflows, and the main contribution of this paper is that we're using OPQL, Open Provenance Query Language, for querying and storing big data, and we transferred that in the Pig Latin so that it's scalable and it can handle scalable querying also and storing also. So in this process, first I'm going to explain s the main contributions of the papers. Number one, we have transformed OPQL to Pig Latin program. Number two, we supported ProfDM model. And number three, we present an architecture. And number four is our experimental section where we get the data from UTPB benchmark, and we have done the experiment based on the prof data generated by UTPB. First of all, I want to mention about the prof models. So before we have OPM model, but now as we go on we have the ProfDM model. It has before we called agent and process, where we call now entity and activity, and also based on the relations there are few more relations when you see in ProfDM. So in the picture you can see both picture side by side to make a good comparison. If you see in there, like for the agent, there's in here there's one additional acted on behalf of, which was not there before. So there are a few more relations in there. And one other good thing about ProfDM is it stores the provenance of provenance. But this on this paper we are not going to that level. We are on the core ProfDM model. So for the next section, here is the overall architecture when we're transforming from OPQL to Pig, and we call that OPQL Pig architecture. In here, if you can see, we can get the data models from all kind of from triple RDF triple, and then we load the data to the in here. If you can see, Hadoop distributed file system. After data is loaded on the Hadoop distributed file system, the query, then next phase is the query, and all these together we call OPQL Pig system. And in the query it goes to the OPQL parser and then transform to the Pig Latin. Below I have the way all the codes algorithm how I transformed from OPQL to Pig Latin. I'll explain it later. So and in here if you can see Apache Pig and query execution, how that can be done in the architecture. Next level, in the Pig is already underlined. MapReduce framework is underlined over there, and it's working on Apache Hadoop. So in the architecture, if you can see, this is the full architecture of how we can transform from OPQL to Pig Latin by storing and querying. So for the next stage, I would like to say that so here's the equations for our ProfDM model. So if you can see, so I explained some of the relations over here. So from activity to entity, from entity to activity, used, was generated by, was controlled by. So these are the relation. But when it comes to the multi-step construct, we need first go to one step and then the loop of that step. So when we discuss about the transforming from OPQL to Pig, I'll show you how this loop is, how we control this loop and how this loop executed over there. So for this one, I'd like to show you. So this is the code I was talking about. So in here, if you can see, we are providing the data file and the data product. So when so we prepare our data. So if you can see in the architecture part, so in the architecture we prepare data first. So in here we load the data, we prepare the data in here, data loading. So we done some pre-processing, and after that we have done this transformation. So in here we give what we have given. If you can see by the code, like, so we have given the our whole data file and also the data product. This is just the so we are just loading. Number one is this one, number two is the file name, number two is the node name, and then we call the pig command. And in here what we have done, we actually handle the loop in here, and we use the Hadoop file structure, and we transform. So this one is specifically right here, we say wdf.star. So we are giving that was derived from. So for the multiple iteration, you need to go one step, and then from there getting all the nodes from there. So when it comes here, so I can show you for single step construction, and then go to the multi-step. So this function 2 is for the single step construction. In here, starting node and ending node, we also mention the type of the nodes. Is it entity or is it activity? So we mentioned that one. So first one is the source, then the source type, next one is the destination and destination type, and what is the relation. So we are here trying to find out, first getting the input, and if filter by a we are using the filter function, and if its relation is USD, that's used, then we for each x, as we have defined here, so we got the y's. So in here we get the next the relation. So if we give x, we'll get the y from there. So when we go to the multi-level one, so for each x we store it. So if you can see in here, we load that one. Is this is just the typical pig Latin syntax. Then we load one x here, then we filter by was derived from, and the other one we got here, and we filter by, and then we do the join based on the destination. So and then for each z, as you can see from here, we generate the result, and we store it in the my result USD, in that folder, so that all the results, all the files are to be there. And so after we store that, then how can we do the union of both? So because in here we want to get all the, so suppose the query is we want to get all the activities which are involved in the process, in the process of that metadata. So when we are using that, how can we get all the activities from them? So here we use the union construct, and in this code, if you can see, like, we are doing, we are gathering all the results, and last of all we are doing union. If you can see, for z and for t, you make the union and put the final result in the results result attribute. So that's the code. And also for that one, we already have built-in construct in our data view. So in there, I can also show you, let me show you in different video, but in this video just explain it. So in here you can see we have a USD construct. So there's default construct we in the built-in we develop, and then we get the our data set, and then the query, and we get the final result in our Dropbox. So we can also get we can get the result from the Dropbox, and we can also store the result to Dropbox. In that way, it's more easy for the developers to to as the built-in construct is already there, just to drag and drop and do the query. They don't need to deal with any underlying complexity of how to do it. They can just drag and just to see, like, the result of that construct. So basically this is the way it is. And so this graph is just to show, like, we are getting this data from UTPB, so we are just showing it's a very big data. We get the triples in millions and the size of the data in megabytes. So as you can see, we handle very big data over here, and we get the result based on the big data. Thank you all so much. In my next video, I'll also explain more about this construct and in data view, and I'll run the construct for you in the data view and show it to you. Thank you. Bye.